Hey, what's going on, guys? Let's try this problem right here. Here what we are trying to do is we are trying to find these voltages using nodal analysis method. Now in order to use nodal analysis method, we have to follow these 7 steps. The first step is we have to find a reference node with a known voltage. The best thing to do here is we attach this bottom part to the ground. In that way this is going to become 0 voltage, so we don't have to worry about these nodes, right? And the second one is assign voltage to the other nodes. So we have totally 4 nodes, 1 2 3 4, and this is attached to the ground, so 0 voltage right here. So these two we don't know, right? So we put v1 v2, so that's the one we are going to find. And the third step is assign currents to each branch. So we have 3 ampere right here, and this one we don't have anything, so we put I2. Like you can put I1, I2, I3 anywhere, like, and the direction also doesn't matter, because if you get a wrong direction it gives you negative answer, so it means the negative represents opposite side, so the answer is always going to be right? So we don't have to worry about the direction, so you can put any direction. And the main thing is we have to put currents everywhere, like here we have I1, I2, I3, right? And here also we have current, so wherever we don't have current we put I1, I2, I3, right? So that way we have current everywhere. And this next step is apply Kirchhoff's current law to each node. Kirchhoff's current law is basically whatever the current that enters must exit. So here we can apply in different places. First of all, let's see. Here we have 3 ampere and I1 entering, and we have I2 exiting, right? So we can create an equation using these two. So we can create like 3 plus I1 gives us I2. So this is one of our equation. Let's write this one on top. So this is our fourth step, that is 3 plus I1 is equivalent to I2, right? And let's see whether we can apply this one anywhere else. And if you notice, we have I2 entering and we have I3 and 12 ampere is exiting. So we can create another equation using this one. So we can say I2 is equivalent to I3 plus 12 ampere, right? So we have two different equations. Now let's go to the next step. Next step is fifth step. Define each current using Ohm's law. We know that Ohm's law is V is equal to IR, and if we write this one in terms of current is I, right? I is going to be equivalent to V over R. So here what we have to do is wherever we have I, we have to replace this, like we have to find the V over R pattern, like I is equal, let's take I1. So here the voltage drop is going to be what? We have V1 and here 0. So V1 minus 0 divided by the resistance in between, that is 2 ohm. So this is going to be V1 minus 0 divided by 2. So that's going to be I1. Now let's look at I2. I2 we have V1, V2. So the voltage drop is going to be V1 minus V2 divided by the resistance in between, that is 6. So this is going to be V1 minus V2 6. So actually, since the current is going in this direction, I have to put 0 minus V1, right? So this is going to be 0 minus V1, and this is V1 minus V2, and the third one I3 is going to be V2 minus 0 over the resistance in between, that is 7, right? So we have 3 different equations. Now let's look at the sixth part. Sixth part is substitute the current definition into the node current equations. That is the first one. That's the fourth step. We have 2 different Kirchhoff's law equations. So what we have to do is we have to get this equation and replace I1, I2, I3 with voltages. So let's do that part. First we have 3 plus I1 is going to be minus V1 over 2, right? And then I2 is going to be what? V1 minus v2 over 6. So this is our first equation. Now let's look at the next one. The next one is we have I2 is equal to I3 plus 12. So this is 12, right? And let's write this one in terms of voltage. So here we have I2 is V1 minus V2 over 6, V1 minus V2 over 6, and I3 is equivalent to V2 over 7 and plus 12, right? Now here the main thing we try to do is we get rid of these denominators. In the first one we have to find a number. If you multiply, all the denominators will cancel. So that way we can easily do this question, right? So what we can do is, if you notice, if I multiply this equation by 6, that will become an equation without denominators. So let's multiply this one by 6, and if you multiply this one by 6, you will get this equation, that is, so this is multiplied by 6, 3 times 6 is going to be 18, plus here we have 2, right? So 3 will be on top, so we are going to have minus 3v1, and then in the other side we are going to just have v1 minus v2. And the next equation what we can do is we can multiply this one by, so we have 6, 7, the common denominator can be 42, right? 7 times 6 42. So if we multiply this one by 42, all the denominator will cancel. So in that way we can get the new equation, that is going to be 7. So if I multiply this one by 42, that's going to become 7. So 7 v1 minus 7 v2, because if I multiply this one by 7, it multiplies both of them, right? 7 v1 minus 7 v2, and in the other side we are going to have 6 v2 plus 12 times 42, that's going to give us 504. So we have two different equations. Now the best thing to do here is we can take the v's to one side and all the numbers to the other side. So let's continue. So this is the equation we are dealing with. Let's continue this one right here. So here what we are going to do is we have these two set of equation. Let's bring all the v1 v2 to one side. So first we can take this v1 to this side, that's going to make this one negative 4v1, plus also we have a v2. If I bring this one to this side, that's going to become positive v2, and the other side we are going to have 18 right here, right? So if I move this one to this side, that's going to become negative 18, I guess. Let's see, it seems like there's a mistake. 3 plus, okay, let's see, 3 plus I1 okay, yeah, this should be negative 18, right? Negative 18, and then we have 7v1 minus 7v2 is equal to 6v2 plus 504. So if I bring this 6v2 to this side, that's going to become negative 13, because this is going to be minus 6v2, so this is minus 7v2, so that's going to become 7v1 minus 13v2 is equivalent to 504, right? Now these are the two equations we have. Now let's see what we can do with this. So here the easiest method we can do is, if you notice we have negative 13v2, so if I make this v2 also 13 and add them together, the v2 cancels, then we can solve for v2, right? So let's do that one. So we multiply this one by 30, and if you multiply this one by 13, that's gonna give you negative 52 v1, and then we are going to have plus 13 v2, and we are going to have negative 234, right? So this is what we get. Now all you have to do is add these two together, right? In that way V2 cancels, so this is 234, right? 234, and in this way V2 cancels and we are left with these things. Now negative 52 V1 plus 7 V1, that's going to give us minus 45 V1. That's equivalent to minus 234 plus 504, that's going to give us 270. Therefore V1 is going to be negative 6 voltage. So if V1 is negative 6 voltage, then we can plug this into this equation and solve for V2. And if you calculate V2, you should get negative 42 voltage. Since we have V1 and V2, now we can go ahead and find the current too, right? Because we have all the voltage, so this will be minus 6, because we know that V1 is 6 voltage, negative 6 voltage, so this is going to be plus minus 6, that's going to become plus 6 divided by 2, that's going to give us 3 ampere, right? So this is going to be 3 ampere, and here we have V1 minus V2, that's going to be minus 6 minus 42, that's going to be plus 42, plus 42 minus 6, that's 34, right? Actually that is 36. 36 divided by 6, that's going to give us 6 ampere, and this is going to be minus 42 divided by 7, that's going to give us minus 6 voltage, right? Minus 6 ampere. So now we have all the voltages and ampere, and that's it. That's how we do nodal analysis method. I hope this video was helpful to you. See you next time.